Okay, now just looking at the basic form of some of the more regular or some of the more common quadratic functions, or just looking at some of the basic forms of some of the more common functions. Let's look at the first one, which is quadratic function. And a quadratic function, if we're talking about, a quadratic function where the x squared term is positive, well, it's going to have a positive upturn. That means it's going to go like this. I think I might have described it like it's a smiley face. Whereas if the leading coefficient is negative, then you can think of it as like a frowny face there. That's the way I've always remembered from high school. And when you do this, if I make a really quick table here of x and f of x. Now remember, f of x is just the y. It's the output. So if I just do some basic values here, 0, well, 0 squared is still 0. If I do 1, well, 1 squared is still 1. If I do negative 1, well, negative 1 squared means negative 1 times negative 1, which is also 1. And if we do 2, well, that's square that's going to be 4. And then negative 2 is also going to be 4. So just kind of just doing some general points here. We've got 0, 0. We've got 1, 1 right here. We've got we've got negative 1, 1 right there. We have 2, 4, which is right there. And then we have negative 2, 4, which is right there. So there's the general makeup of what a quadratic function looks like. The vertex is right there at the origin. And that's when it's in its basic form, which is f of x equals x squared. So what we're going to do is we're going to talk about how these graphs shift. These quadratics, based on the way based on what the equation is telling us, it may have a vertical shift, which means it's going to go up or down. You could have a vertical negative shift, I guess. So vertical doesn't necessarily mean all up. It just means up and down. So a vertical shift of 1, it might be a vertical shift of 2, it might be a negative vertical shift, It might be a horizontal shift, where it goes right 2 or it goes left 2. And it might be, in some cases, we're going to get there. I know that it might be where the shift is kind of a combination, where it's vertical and it's horizontal. So maybe it shifted up 2 and then went right 3. Now notice the quadratic function that I'm dragging around is not changing its shape. It's still that general shape that it started out as. It's just that these points are now at different spots. So if I put it right here, you can kind of see where those points are. They're in different location. They're still meaningful. So if we're going to talk about the, reviewing basic shifts, then there's the parent function. If we have the parent function is going to look something like this. All right, so there's your parent function. And then the shift, if we're looking at horizontal shifts, or if we're looking at vertical shifts, I should start with that first, then this number, either plus or minus, is going to dictate to you whether it's going to shift up or it's going to shift down on the vertical axis. So if I have something like this, x squared plus 3, then that's going to shift up 3 units. So I'm just going to take all these points, 1, 2, 3, and I'm just going to shift them up 3. And I kind of run out of space to work with here, but there it is. So that tells you it's vertical, right? That tells you whether it's going to go vertically positive or vertically negative. Vertically positive means up, vertically negative obviously means down. Back to the same type of graph here, quadratic. Now when you have parentheses, when you have grouping symbols around it like this, well, that is going to indicate right here that that is a horizontal shift. Now remember, with horizontal shifts, those are a little bit weird and they always throw people off. But the horizontal shift, if it says -1, it really means right. It sounds like it should be left 1, but it means right 1 unit. If it says +1, it means left 1 unit. So it's a little bit different, a little bit backwards, and that's what's going to happen there. And then let me show you something that's got kind of a little bit of both. Okay, so we have the function of f of x equals x plus 3 all squared minus 4. So what does this tell us? This tells us that this is going to go to the left 3 units, left 3, and then the vertical shift is going to go down 4. So if I were to graph it, then I'm going to go down 4, 1, 2, 3, 4, and then go left 3, 1, 2, 3. Now looking at example 1 right here, this is telling us that it has a horizontal shift. It has a horizontal shift of left 3 units, and then it has a vertical shift of up 3. Now remember, when it comes to vertical and when it comes to the vertical shifts, it's always going to be up or down, and if it's positive, it's up. If it's negative, it's down. But when it comes to the horizontal, everything's backwards. I know I keep saying that, but it's worth reminding. Okay, so the vertical shift means we're going to go up 3 and then left 3. So 1, 2, 3, 1, 2, 3, and there it is. And I was able to put a few points on that graph, but that's where it is. So it went up 3, and then it went left 3. That's it. Now remember, we're always talking about with respect to wherever the parent function is. Now number 2 is just describing a vertical shift. So that means up 4. And that's it. So I'm going to go up 4, 1, 2, 3, 4. And there it is. And if you don't believe that, if you don't feel like you're doing it the right way, because I think sometimes when it comes to graphing, some of us are a little bit uneasy as like, am I doing these right? But that is 0.15 right there. And let's say I plug that in to the g of x equation. And I put in 1 for x. So 1 squared plus 4. Does that give us an output of 5? And it should. 1 squared is 1. 1 plus 4 is 5. So that all works out. Now for number 3, we've got our parent graph right there, which is f of x equals x squared. And I should probably be graphing these. I don't think it's going to harm you at all to graph the parent functions as well. I think that's a great idea, actually. That's usually my suggestion to people when they're doing these, is draw that parent graph, because I think sometimes, I know I have these kind of committed to memory and I can see them, but these don't always come naturally to everybody. So according to the transformation, the g of x, what we have going on here is we have a minus 2. Now what is that? Is that vertical or is that horizontal shift? Well, vertical would be either plus or minus after, but that's not indicated here. That is going to be horizontal. Now if we said it 100 million times already, minus 2 sounds like left 2, but it's actually right 2 units. Okay, so that's all that. This one does not have a vertical shift, it just has a horizontal shift. So I'm just going to go right 2 units with all these points. So I'm going to take that point and just move it over 2. I'm going to take this point, move it over 2. This one's going to move over 2. And there's your transformation. You have your g of x right there. Okay, now moving on to graphing f of x equations in the format of a times x minus h squared plus k. So a bunch of unfamiliar looking variables here, but we're going to make some sense out of these. If you have a function that is in that format, you're going to see those when you guys are practicing these. If you see a function that's in that format, there's going to be a lot of things that tell you what's going on. All right, and so if we're dealing with the vertex, if you want to find the vertex, well, the vertex is a point. It's a point on that coordinate plane, and the point is going to be the h. That's going to be like your x, and your k is going to be your y. So these numbers right here, that h right there and that k right there, represent in some sense the points that make up your x and your y. So that will be your vertex. The axis of symmetry is going to be x equals, and I believe it's your h You're going to put your h there. So that's going to tell you where that, especially if we're talking about a parabola, because that's what we're looking at right here. If we're looking at a parabola, well, parabolas are symmetric, and they're going to have a line of symmetry that cuts them in half. And if you know what one half looks like, well, then the other half obviously is going to be, like if you know what one half looks like, then you know the other half is going to be a mirror reflection. So it's kind of nice to know how parabolas work, because you really just need half the information, because the other half is going to be symmetric to what it is. And then this is something that maybe we talked about before. I can't remember if we did, but I'm going to go ahead and mention this. It's opening upward if it has if A is positive. Okay, so if A is positive, if the leading coefficient, if we're talking about this thing right here, if the leading coefficient is positive, then it's going to be smiling. It's like a smiley face. And if its leading coefficient is negative, it's going to be frowning. It's going to open downward. Okay, so the next thing is if you want to look at how wide or narrow a parabola is. Okay, because you can have all different shapes of parabolas. You can have parabolas that are pretty narrow, and sometimes you have parabolas that are quite broad, something like that. There's going to be some things that tell you what is what. There's going to be some things that tell you what's going on. This is a lot to take in. It's all about that A value. Now I've got the absolute value signs around the A value. And if the A is less than 1, if A is less than 1, well, what are some numbers that are less than 1? Well, 3/4 is less than 1. 1/2 obviously is less than 1. 9/10 is a little bit less than 1. 1/100th is a lot less than 1. If we're talking about values that are less than 1, then it's going to make it wider. So that's what's going on there. And then, as you can expect, if the absolute value of A is greater than 1, what do you think that means? Yep, it's going to be narrower, meaning something like that. Whereas the the width of it is something like that. Now, when it comes down to finding your x-intercepts, and sorry if I'm not getting into too much detail here, but we will when we get into our examples. The x-intercepts are the roots. Those are your zeros. You have to solve for it, and that's what you're going to get. If you want to figure out your y-intercepts, is going to be, going back up here, it's going to be your k. So figure out what your k is, and then that's what it is. Okay, so now moving to number 4, our first example here, we've got f of x equals 2/3 times x minus 4 squared. Now, according to our h and our k, we should be able to figure out our vertex. Now, our vertex is our hk. So the h tells us the horizontal shift. Now, so it says minus 4, but that really means plus 4. So minus 1, 2, 3, 4, and then we're going to go up 1. All right, so there's your vertex. Now, if that's your vertex, you can also bet that is where your axis of symmetry is also going to go through. Right here, if we look at how narrow or how broad that parabola is going to be, it says we've got 2/3. Now, that's less than 1. Now, if I go back to my notes here, go back to what we said here, well, less than 1 is telling us it's going to be a wider. Now, if it was a basic parabola, now the parent parabola would look something like that. But I'm going to make 2/3 be a little bit wider. I mean, not that much wider, but I'm going to make it a little bit wider. And I'm not doing this perfectly, but that's good enough for our graph. Now for number 5 right here. Here's our h, here's our k. And It may appear like we don't have an a, but we do. Our a is 1. So our vertex is going to be left 2, so minus 2 on the x, and then it's going to be minus 4 vertically. Negative 2, negative 4 is going to be right here, and that's also where your axis of symmetry is going to fall. If you're looking at how narrow or how broad it is, well, it's not changed since a is equal to 1, so we can kind of follow general parent. So I'm not drawing these always very nicely, but for this next example right here, we have a negative sign right here, which indicates that it's opening down. You know, it's reflecting, it's inverted along the x-axis. And according to our h and our k, our vertex is going to be negative 2, positive 4. So left 2, up 4, right there. Now this parent function right here, if we look at the parent function, f of x equals negative x squared, well, that would be a pretty typical parabola, except it's just inverted. It's going upside down. So that's what it looks like. Okay, now moving on to steps for graphing parabolas from the form of f of x equals ax squared plus bx plus c. And we're looking at the completing the square example first. Now, I don't expect you guys all to remember how to complete the square. But when you do complete the square, there are some important things that you need to remember. Number one is that the leading coefficient, you know, the term, the a, that has to be positive. And you know what? Not only should it be positive, it should be 1. We want that to be 1. If it's not 1, we want to factor out that number so that it is a 1. So it sometimes takes division. Number 2, make sure to separate the constant from the variable terms. What that basically just means is, like, if you have, let's say we have x squared plus 5x minus 7 equals 0. All right, that definitely looks like a quadratic equation. You know, it's not in the format that we want. We want to get that negative 7 over here. So if I want to start completing the square, I better get it to look like this first. Now nothing's been completed on that, but that's what it should at least start out as. X squared, all right, the leading coefficient of that is 1. These are both the x terms. This is your constant term. It's on the opposite side. So that's important. Now it doesn't matter if that constant is positive or negative. I mean, sometimes you'll notice that it does kind of make a difference, whether it's positive or negative in terms of how your solution comes out, but it doesn't matter. And then for step 3, you're going to complete the square. Which, you know, if I just kind of do a quick example here. Okay, so let's say I had the quadratic that looked like this to start off. Now remember, when you complete the square, you take the b term and you divide it by 2. So 8 divided by 2 is 4. And then what you do is you square it. Well, 4 squared is 16. And then whatever that number is, you add that to both sides. So now we have x squared plus 8x plus 16 equals 25. And then this side should be a PST. And the right side, I mean, it just kind of came out that way. But the right side is a perfect square, which makes it perfectly suited for doing the square root property. Now, finding the vertex using the vertex formula. Now, the vertex formula is x equals negative b over 2a. So you want to use the vertex formula. As long as you know what the a and the b are, you're good. Okay, let's start out here by finding the vertex first. So the a is 1, the b is negative 4, and the c is 10. So if I want to find the vertex, it's going to be negative b over 2a. Well, negative b is going to be negative 4. 2 times a is going to be 2 times 1. Well, negative 4 is just 4. 4 divided by 2 is 2. So there's, if we're looking at our vertex, there's your x right there. Now we're going to look for our y, but we don't really call it y, we call it really f of x. But that's where we're basically looking for our y. Now if you want to know what your y is, just plug that 2 into the original quadratic. So you've got x squared minus 4x plus 10. Well, you're going to do 2 squared minus 4 times 2 plus 10, and that's going to equal your y, or in other words, your f of x. So there is your vertex. We've got 2, 6. Now I'm going to kind of erase my workspace here so they have more room to work. You, of course, can just use some extra paper or whatever. All right, so next thing I want to do, we want to complete the square. I should also indicate that that's our y-intercept right there, 10. So I know there's going to be a point there. Okay, now that I've got the x's on one side and I have the constants on the other, I'm going to take this, divide it by 2. Well, negative 4 divided by 2 is negative 2, and then negative 2 squared is 4. So you're going to have x squared minus 4x plus 4 equals negative 10 plus 4. The left side of it is a PST, which is going to be x minus 2 squared, and you're going to make that equal to negative 6. Now I want to get it into that format. So now I'm going to take that negative 6 and I'm going to bring it back over. So I'm going to put it all together now. F of x equals x minus 2 squared plus k, plus 6. You know that your k is 6. Now our vertex is also telling us what our axis of symmetry is. So our axis of symmetry goes along that imaginary line right there. So the parabola, according to what we have so far, we know that it's opening upward. So if I know that there's a point right there, well, that is going to be a mirror image with the other point, which is going to be right there. That's 2 away from that axis of symmetry. And there it is. Okay, moving on to number 8, let's go ahead and just complete the square on this one. I'm going to multiply everything by, kind of make that our priority, because I want to get that leading coefficient equal to 1. I'm even going to multiply the f of x by 2, and you'll see how that will kind of turn out at the end here. So 1/2 times 2 is just going to be 1. Okay, and next what I'm going to do is just take half of the b term, and then you square that, you get 64. And the reason I'm going to take away 64 is because it was at one point over here. It was, you add 64 when you complete the square. You add both those to one side, but I want to keep it over onto one side, so I'm going to get rid of that right there. And I mean, this is kind of a one-off type situation here. We don't do this quite often, but just kind of work with me here. Let's see. Now this is a PST, perfect square trinomial, and I'm not going to do anything with that yet. And then what I'm going to do is I'm going to divide both sides by 2. And that's going to give us, those are going to cancel, and then left with f of x, which is ultimately the goal there. Now I know this is a 2 here. There's a 1 here. You don't necessarily see it, but it's there. So I'm going to think of that as 1/2 times x minus 8 squared. And then 6 divided by 2 is 3. And the reason I did that is so that we get that the vertex. Now the vertex, once we have it in this form, the vertex is going to be right 8. I know that says minus 8, but remember that's all backwards. So it's going to be right 8 and then down 3. So it's going to be right 8, down 3. So that's where the vertex is, right there. And then if we go back to the very, very beginning of this problem, the plus 29 is your y-intercept. And, of course, our graph only goes to 10. So, if I were to, I guess, I'm not going to really do this, but, if that's 10, then this is 20. So 29 is going to be even further up. So what I'm saying here is that the vertex of it, if I were to, I'm just eyeballing this, this is a terrible drawing, by the way, but what is most important is that we kind of got the form of the equation. I think the goal here is to get the form of the equation and knowing what that vertex was. And that's all you had to do for number 8. Okay, now for number 9, we're going to use the vertex formula. So the vertex formula says A equals 1, B equals -4, and C equals 4. So the vertex formula is negative B over 2A. So we have -4 minus, minus -4 over 2 times A, so 2 times 1. So it's really 4 divided by 2, which is 2. So there's that, and now we're going to take that 2 and we're going to plug that into the equation. So we got 2 squared minus 4 times 2 plus 4. Well, 2 squared is 4 minus 8 plus 4. Well, 4 minus 8 is -4. -4 plus 4 is 0. So there's your vertex right there. So your vertex is going to be 2, 0. So over 2. And then don't go up or down anything. There's your graph right there. It has a y-intercept of 4. Okay, moving on to number 10 here. According to this quadratic, our A is -1, so it's going to open downward because it's negative. Our B is -2, and our C is 3. So using the quadratic formula says negative B, so negative, minus, minus 2 over 2A. Well, negative 2 means plus 2, and this could be minus 2. And then 2 divided by -2 is -1. So there's half of our vertex right there. Our half of our vertex is going to be -1 something. So now I'm going to put that negative wherever I see an x. Now I'm going to be very careful because I'm putting a negative in, and there's a lot of negatives in this problem. So I'm going to write that whole thing out, but instead of writing x everywhere I see an x, I'm going to put parentheses. And we're going to put -1 in the place of x. All right, so parentheses first, -1 squared is 1. Well, that negative is going to drop down, so it's going to be -1. A negative times a negative is positive, so it's going to be plus 2, plus 3. Well, -1 plus 2 is 1. 1 plus 3 is 4. So there's the other half of your vertex right there. So -1, 4. And remember, when you find your vertex, you've also found your axis of symmetry. Remember, that's your imaginary line that kind of splits your parabola in half. You get the general idea of what it looks like. Now, according to this quadratic, this has got a y-intercept of 3. So there's a point there. So if there's a point there, the other point should be symmetric to that other point, so there should be a point right there as well. All right, now this one, I'm going to anticipate that this one is going to go through the x, is going to have some x-intercepts. So what we're going to do is we're going to take that equation, -x squared minus 2x plus 3, set it equal to 0, but I'm going to divide by -1. So divide everything by -1, which in turn is going to change the signs of everything except for 0. So you're going to get x squared plus 2x minus 3 equals 0. And then if I do the factor sum method, let's see if I get some real numbers here. So you got x, well, we have our product of 3. Well, 3, the only products that make 3 is 3 times 1. and we need to make those into positive 2. Well, the only way to make positive 2 out of that would be plus 3. So there's your roots right there. So you got x equals negative 3, and you got x equals 1 when you solve those. So there's a root right there, and then you have negative 3 right there. So we have a lot of information here now that we can use to graph this and get a good picture. And this is probably our most accurate graphing picture in terms of all the information we've gathered from the equation to graph it. Going on to number 11, let's find our vertex. Our A is 2. Our B is negative 8. Our C is 11. So vertex is negative B, so negative negative 8 minus minus 8 over 2 times A, which is going to be 2 times 2. Well, negative negative 8 is 8. 2 times 2 is 4. 8 divided by 4 is 2. So there's half of your vertex. Now if you want to figure out the other point that makes your vertex, put that 2 into the equation. Using that vertex formula, we got a vertex of 2, 3. Now this is opening upward, and we know that that has a y-intercept of 11, which is just off our graph, so I'm going to kind of put one right there. And I didn't do this earlier, but the axis of symmetry goes along this imaginary line. So if the y-intercept is right there, then you can imagine that the reflection of that point would be somewhere around there. And there's a good general idea of what your graph looks like. Now this was quite a bit. We did quite a lot in this section here, 12.3. This was pretty heavy, so pretty dense in terms of all the material that we covered. So make sure you guys take good notes. Make sure if you don't understand something, let me know, and I'll get back to you, and I can help you out. And remember, if you want to get extra help, just let me know, and we could do a Google Meet or Zoom or whatever you guys choose. I have Zoom on my iPad as well, if you want to do that. I kind of prefer Meets because that's what my school district uses. And if you want to reach out to me and let me know like what's going on, you need some help, let's do that. And let's try to get through the rest of this year as best we can. So everyone stay safe, stay healthy. See ya. Take care.